This is the solution to problem 33 from homework 3.2 day 1. We're asked to find the real zeros of the polynomial function and then the multiplicity of each zero. The multiplicity is how many times does that zero occur in the function. So to find zeros, real or otherwise, we need to set y equal to 0, which in this case is f of x. So the equation we need to solve is 0 is equal to 3x cubed minus 12x squared plus 3x. And if we can factor, that will be the easiest way to solve this equation. So I'm going to take out the GCF, which is 3x. That leaves us with x squared minus 4x plus 1. By the zero product property, I can set each one of these factors equal to 0. So I say 3x equals to 0 and x squared minus 4x plus 1 equals 0. Solving the first equation, I would divide both sides of the equation by 3, and I would get x equals 0. That's one of our zeros. X squared minus 4x plus 1 is a quadratic equation. We can't factor it, so we can solve that in two ways. We can either complete the square, or we can use the quadratic formula. I'll do it both ways. Depending on which way you like, you can do it either way. So completing the square, I would do x squared minus 4x. I would bring the negative 1 to the other side. This is going to be a little different than when we completed the square form. So now to complete the square, the value that we need to add is b over 2. So that's negative 4 over 2 squared. So I'm going to add 4 to both sides of the equation. And now the left side of the equation is a perfect square trinomial that factors as x minus 2 quantity squared. The right side of the equation is 3. And to solve that, I'm going to take the square root, extract square roots of both sides, and I'm going to get x minus 2 equals plus or minus rad 3. Bringing the 2 to the other side, I'll get x equals 2 plus or minus rad 3. So our three zeros are 0 and 2 plus rad 3, 2 minus rad 3, and all of these zeros have a multiplicity of 1. So, and the 1 is an odd number, so they all have odd multiplicity. I'm going to use quadratic formula to find the two zeros that come from x squared minus 4x plus 1, just in case you are a fan of the quadratic formula. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll substitute in the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 1, and c, which is 1, all over 2 times a, which is 1. Simplifying this, we'll get 4 plus or minus the square root of 16 minus 4 over 2, which is 4 plus or minus rad 12 over 2, which is 4 plus or minus 2 rad 3 over 2. And then simplifying that, we can divide out a 2 from every term. So this is going to be 2 plus or minus rad 3, which are the same zeros we found by completing the square.